Okay, after talking about processes and cycles, let's go to describe another term, that is a temperature. Okay, why we need to talk about temperature? Because although all of us know what temperature is by our daily experience, it is beneficial if we know how this term comes up. Okay, recall the meaning of thermal equilibrium. Okay, it describes systems with no heat flow. Okay, by daily experience, we know that if a cup of hot water is placed in a room, it will gradually cool down to room temperature. At this time, there will be no any heat transfer between the water and the room, and the two systems, we will use a term to describe that is a thermal equilibrium. And in this case, we can see that thermal equilibrium is ensured only by the equality of temperature. This is actually the consequence of the zeroth law of thermodynamics. It states that if the two bodies are in thermal equilibrium with the third body respectively, then the two bodies are also in equilibrium. Okay? And if we replace the third body by a thermometer, we get another statement is that if two bodies have the same temperature, then they will be in thermal equilibrium. Okay? And the converse will be also true. Okay? Well, next we will talk about something related to the temperature scale. But the most commonly used temperature scale is Celsius scale. It uses the ice point as well as the steam points of water at 1 atm to define the scale, namely 0 degrees C for ice point and 100 degrees C for the boiling point. This is also called a 2-point scale. Okay? A commonly used 2-point scale in English system would be the Fahrenheit scale. However, in thermodynamics, we need a temperature scale that is not defined by using any pure substance. We call this kind of temperature scale the thermodynamic temperature scale. Okay? The thermodynamic temperature scale in SI is Kelvin with units K. Okay? Kelvin with units K. And the English system counterpart is called Rankine. Okay? Rankine with units R. The conversion between Celsius and Kelvin temperature is given by this formula. Okay? That's the temperature in Kelvin will be equal to the temperature in degrees C plus 273. Okay, 273. Okay, the lowest temperature that can be reached in the universe is called the absolute zero, or we call that 0K. Okay, so that the temperature in Kelvin would be always non-negative. Okay, it would not be negative for all of the time. Okay, it must be either positive or zero. Okay, if it is 0K, then it will be absolute zero. Okay. Okay, there are some reminder about the use of Kelvin scale as well as the Celsius scale. Okay, if we are considering the temperature difference, remember that the division of Kelvin scale and Celsius scales are the same, because this formula is just the translation, okay, of the temperature in degrees C by 273 units, okay, to become the temperature in Kelvin. Okay. Therefore, if the temperature difference is given in degrees C, then there is no need to convert it to Kelvin before actual computation. However, if one is asked to use the temperature given in degrees Celsius to do calculation, conversion to Kelvin is a must-do procedure. Okay? If you just have the temperature, okay, you must convert it to Kelvin. But if you are given the temperature difference, okay, because the 273 would be cancelled afterwards after subtracting, okay, so that you can also use degree C. Okay. Bear in mind about that, because this is a common mistake that many students would have, as we will see in the homework as well as exam. Okay. Okay, that is a very little account of temperature.